we have all this information, right? We have demographic information, we have medical information, we have lots of data. Why don't we just throw all that in a big bucket and see what the, you know, what the machine learning model decides to take, and then we can just make choices based on that? I mean, why do we have to do more than that?
Yeah, so the thing is, right, we don't have that many examples to learn from all the time, right? If we had an infinite number of examples that we could feed it to say, you know, like let's say we're just trying to distinguish between, you know, a picture of a cat and a dog. If we have 100 million pictures of cats and 100 million pictures of dogs and they're all labeled, no problem. I mean, you could give it all the pixels and the pixel values and an image. You could also add in probably, like I said, temperatures across the face of the earth. It would still figure it out, right? But if you throw all that extra information in, there's lots of patterns in everything. It can potentially find patterns that match your data, but a lot of that is noise. It's noise to the problem space. I mean, even if it's not noise in real life, you know, it's a real pattern, but it's noise in terms of it confuses the learner. It can potentially associate that with the data that you're seeing, even though we know it's not related. So that's why if you can build in human expertise to say, you know, we know that this is where we want to nudge the machine. You know, this is the bias that we think will help it solve the problem.